Hey guys, and welcome back. My name is Lowsley-Williams, and today I'm going to be going through the sample Docker-Compose project and show you how it connects to the cloud and how to set up a cloud database when you're utilizing this kind of project. We're not going to be deploying the full project to the cloud. We're just going to be utilizing a database that's in the cloud, as when we're working on projects that require collaboration and teamwork, it's a lot easier to have a cloud database that everyone uses that replicates all the changes across everyone's instance, rather than have local databases that we have to, upload those changes and download them whenever they're made. So today we're going to be using AWS RDS, although you can also use Google Cloud SQL. Both of those options are great, but for the purpose of today, we're going to use AWS RDS. The database that we're creating is part of the free tier, so you don't have to worry about being charged, and it's pretty easy to use. So that's what we're going to be doing. And kind of just to talk briefly about the benefits of using a cloud database, it really makes sense for us to use one because not only are they free, but they do help with the collaboration on projects, and they also kind of typically have a lot of less problems with them. The database as a service is fully managed by AWS, so we don't have to worry about any of those problems occurring. So we're going to go ahead and get started here with AWS RDS by taking a look at the panel. So like I said, we're going to go ahead and bring up that AWS panel, as you can see right here. As you can see, you're greeted by this dashboard page. There's a few options on here that you can choose from. You can see your database instances. You can see other information about databases. To get here, you're going to click on the Services tab in the top left corner and select RDS. You can also select it from the list of options there, or you can search it and select it right there as such. That'll get you to this page, and we'll be able to kind of continue from there. One thing that I want to note about RDS is that we are going to be using RDS because it is their relational database system. MySQL is a relational language, so we're going to want to use the relational database system because for obvious reasons. So that's why we're using this. And what we're going to do today is we're going to first set up the database in RDS, but it will take a little bit of time. So that is, while we're kind of waiting for that to set up, I'm going to go through some of the code changes and show you guys the code base of what exactly was changed and how it looks, so we can kind of understand how those changes were propagated, and then we'll ultimately connect with the project. Before that though, I want to kind of touch on DBeaver. So DBeaver is a connection client for MySQL. It's really great. It's open source. It's got a community edition and it's free. I have in past recommended MySQL Workbench. However, they have had copious amounts of issues recently, and I kind of gave up on them. DBeaver is great, and it is the client that I would recommend to connect and manage your database. It's one of the best tools around right now. So coming back to the panel here, we're going to go ahead and click on the Create Database button up at the top and down below. From here, it's going to take us to our Create Database template. As you can see at the top of the page there, we have two methods of creation, standard and easy create. Then we have our engine options, which have Aurora and MySQL and all of that stuff. And then some more settings down below. To start off, we're just going to go ahead and select the MySQL engine because that is the engine that we're going to be using. And when we do that, you can see below some of the settings do change so that they fit the MySQL server, but we'll get to those in just a second. For the easy create option, that is one of the methods we can choose. However, with the easy create, it kind of does majority of the stuff for you. It doesn't let you set some of the more advanced stuff that you want to, so it's kind of limiting in that factor. As you can see down here, it shows you what you can enable and disable after the server has been created. And what we're interested in is that publicly accessible value there. It's default set to no, so we want to go ahead and change that. So we're going to use the standard create option above. Additionally, we're going to want to configure that security group. Now looking down here, we're going to leave the version at the stable default chosen, and we see the templates here in the template section. We have the option of choosing between a production, dev test, and free tier template. The free tier one is the one we're going to be choosing. That is primarily because it is what is included in the free tier. We do not want to choose production because production is going to be really expensive, large scale, and dev test is also not for us because that's for a larger group. For the purposes of this project, free tier really suits our needs, and we don't need to go any larger than that. Then under settings, we're going to have to kind of set a database instance identifier. So here we're just going to name it sample docker-compose. You can name it whatever you want. It just has to be unique to your account. You can't have any other databases under the same instance identifier. So just keep that in mind. For the connections details, we're going to leave the username as admin, although you can change it to whatever you please. And then we're going to auto-generate a password because we just would prefer them to create a nice secure password for us. It'll spit that out later on. For the instance size, we're just going to leave those as default, and for the storage, we're also going to leave that at default because it's free tier. For the multi-AZ deployment, we're not going to touch that because that doesn't come with our free tier, and for the default VPC, we're going to leave that to whatever AWS gives you as your default VPC. We don't really need to change that. We don't need to create an additional VPC, but we are interested in the additional connectivity options. So right off the bat, we're going to go ahead and create a new security group. And for the purposes of this project, we're just going to call it sample docker-compose. However, you guys can name it whatever you want. It totally doesn't matter. Just make sure it doesn't conflict with another security group that you've already defined. We're also going to go ahead and check that publicly accessible option to yes, because we do want to be able to access the database from outside of Amazon's network, and we need to do that from our local computer. For the availability zone, we're just going to leave that as no preference, and we're going to keep the default port set to 3306 because that is what MySQL uses by default. For the password authentication, we're going to leave that set as default. We don't want to use an IAM database authentication. That is a little bit more advanced, and for the purpose of this project, we really don't need to change that setting. Then below you can see the estimated monthly costs and all that stuff, which is all included in the free tier, and we're going to go ahead and click that Create Database button on the bottom, and it'll take care of that for us. So now that we've clicked that Create Database function, you can see on this page that we've actually started the creation of the database, and in the top right corner you can view the credential details of the instance that we just created. You can see the master password there and the master username. That password is the randomly generated one that we specified during setup. If you specified a custom password, just remember that one for later, but for now we're definitely not going to close that blue bar at the top there because we are going to need those details when we connect later. Now, while this is getting set up, we're going to go ahead and take a look at the code base and review some of the changes that were made to the project to understand how exactly we are going to be connecting to this database. So taking a look at the code base here, we're looking at the sample docker-compose.yml file. This is our controller file that handles the composition of the containers when using Docker Compose. You can see the two services there. We have the front-end app and the back-end API services. We used to have a back-end DB service, but we are no longer using that since we're using the cloud database. So we just went ahead and removed that. But taking a look at the back-end API, the first thing that we see here is the build line at the very top there, and we're specifying that build to go to the back-end folder. Now, the reason we do that is because in that backend folder, we have our Docker file, and the Docker file has some lines of configuration as to how the image should be created. So if we take a look at that Docker file right now, we can see that at the top we have from node 14, then we specify our working directory, and then expose port 8000. We see a similar type of structure when we look at the front end, except the only difference here is that we're exposing port 3000. That's because React uses port 3000 during development, and we want that port to be accessible from our local computer. Again, we also see that it's using the same working directory, and we'll get to that in just a moment here. So moving on, both containers have the restart always parameter. That basically means that both containers, if they ever fail or segfault or whatever, they will restart and they will always restart, which is definitely something we want to see. Moving down again, we see the working directory in both containers. It's both for user source app. That's basically where all of the files in a given folder, so for the backend folder and for the frontend folder, all of the files in those folders will be placed into that working directory within the container. And you can kind of see a hint of that in the volumes section right below, but we'll get to that in just a second. The next line we see here is the command line for the backend API. Right now we see that it runs a command called yarn run dev. That command is actually specified in our package.json, as you can see right there. It uses the nodemon command, which basically means that any changes that are made, if there's a save or whatever, those changes will trigger a restart on the server so that they're propagated on the server itself. Moving back to this file here, we now can take a look at the volumes. As you can see, we're mounting the backend folder to the user source app folder. The key point here to note is that there's a colon between them. The colon signifies that whatever's on the left-hand side is what's going to be occurring, or what's being referenced to on the local machine, whereas on the right-hand side, it's what's being referenced to in the actual container. So for the left-hand side, basically what we're saying is everything in that backend folder, we want to mount that to our user source app directory within the container. And that basically means that any changes that are made, whether the container's off or running, will be propagated to the container so that we can see those changes. We see the same sort of thing happening down below with the front-end app. We see that it maps the front-end folder to the user source app directory, and it will mount that in such a manner that any changes made will be reflected in the container, whether it's on or off. The next line that we want to take a look at here are the ports. This is the mapping of the ports. So since we're using port 8000, we want to expose that port on our local machine and open it on our container. Again, we see that colon. The left-hand side is the port that's utilized on the local machine, and the right-hand side is what's used in the container. So because the service is running on port 8000 in the container, we want to specify that port to be open on 8000 on the local machine as well. Now looking at the networks, we're using the API network for both of these containers. What that basically means is that the two containers will communicate over a local host connection, and that is because we specified those networks. It basically says run those two containers in the same subnet or network space so that they can communicate over localhost. Then for the front end, we see the stdin open is set to true. That's just something that we have to set because React uses TTY when it runs the server, so we need that set or else it will not run. And kind of noting the command here, the only difference here is that we're using yarn start. That's just specified in the package JSON for React. That's the command that you would use to start the development server. And then at the bottom, we see the depends on. That basically means that the container for the front end will not start until the backend API container starts, and that's what we're specifying there. And then lastly, we are mapping the ports again with port 3000 on both the local machine and the container itself, just like we saw above. So now we're going to go ahead and take a look at the index.js file here. As you can see, we're doing that React.render, and we're getting the element by ID root, and we're going to bootstrap the app.js component right into there. And if we take a look at our index.html, you can see that div with the ID of root that we're basically going to be bootstrapping our application into. So now we're going to go ahead and take a look at the functional React component app.js. So as you can see up here, we're using the state. This is our state information. Basically, we're setting the values. These are the values that we're using for our state. So we have two values of state. So that would be number and values. Number is just a simple string that has a function called setNumber, which will set that value for us. And then we have a values const, which has the set values function, and this is where we store all of those values that we fetch from the database. So that's what's going on there. Then throughout here, we just have some handler functions. These are very basic these ones are very basic handler functions. We have one that fetches the values from the database, sets them. We have one that handles the submission of a new number that we're going to square and insert into the database. And then we have a reset function that will actually reset the database, which means it's going to remove the table and insert a new blank table, or it'll just clear the table out. And then the last function we see here is useEffect. This basically just tells the app to call fetchvals when it initially loads. useEffect gets called on any state change, render change, or anything like that. So that's what's going on there. And then we have our JSX down here, which is actually what we see on the visual representation of what we see on the page. This is the code that does that. And you can see it uses some of those handler functions we saw above, and also some map functions across the values that we saw up there. So that's the functional component in a nutshell. Not really too much going on here. Pretty straightforward. All of this information you can pretty much find on React documentation. If you have any questions, obviously, please let me know, and I'd be more than happy to help you with that kind of stuff. So now we're going to move on to the back end, and this is where we actually see the real changes. And it's kind of funny because there's really not many changes. So the first thing that we want to see is that, in this file, we kind of have our connection, we create our connection at the top here using a bunch of environment variables, which we'll take a look at in just a second. This is the part that changes essentially when we created a cloud configuration. You're going to have to change these variables so that they actually meet what your RDS or Cloud SQL database set them as. You have to change those so that they're actually properly updated and they're correct there according to what you were provided with in that setup. And then we have the config information for the Express app. We actually create our app. This is just us using a bunch of middleware. So we use body parser JSON that automatically parses our JSON. We use cores, which, if you haven't bumped into cores errors, you're going to bump into them soon. It's a protection policy that was put in place. This is just a little hack here that basically allows anything on the same origin to communicate with the server. So just don't worry about that too much. If you want to know more about cores, I would highly suggest that you look into it and research it a little bit more independently. And then we have our logger that we're using for the server that basically logs all the information that we need to, if there's an error or whatever, or if there's just a general action occurring, we log that using our logger. And then we have a function that connects to our database here. Underneath that, we have a default get. So if you go to this, if you go to a web browser and you go to 0000 or localhost colon 8000, it'll tell you to it'll spit this information out to you. So this really doesn't do anything with the app. This is just used in case you accidentally browse to the wrong thing. It tells you to go to the right place. And then underneath that, we have a post request. This is the one that resets the table, right? So you see a bunch of SQL stuff there. Here's the one that actually inserts the value, the multiplied number. And then this is the one that returns all of those values. And then at the bottom here, we have the listen function, which actually listens to the server. One thing that I want to note is that with Express, you have two parameters and callbacks. If you don't know what callbacks are, this is one right here. Basically what a callback does is it's a function that you're passing into a function as a parameter. I know that sounds a little bit crazy and a little bit confusing probably at first, but it's a function that you're passing into a function as a parameter, right? Because this is right here, we're defining a function, right? We have our two parameters of the function, we have an arrow, and then we have our actual function declaration inside there. And we're passing all of that into this app.post function as the second parameter. So what's going on here is basically when that post function gets called, it's going to do some stuff, and then it's going to call this callback. And this callback is going to execute in the context of this file, right? So that's exactly what's happening here. So when we hit the multiply number endpoint, it's going to call the post function, and it's going to say, okay, app.post multiply number, I'm hitting that function, I'm going to need to call this callback. So it's going to call this function here, and then this function inside of it, we actually use the the body that was sent with the request object. We use the response to send information back to the client. And we actually execute our SQL query here. So as you can see, we insert into the data, or into the test table, the products that we received, our body, and then we have another function, callback function here that will spit out information regarding the errors, or if it was successful, we'll return some information about the rows that were inserted and other associated information. So that's what's going on there. I just wanted to bring up the callbacks because that always confuses people. But just realize that it's just a function that's being passed as a parameter into another function. And for Express, with the post and the get roots, this is kind of just default. You're going to always pass in a function to a post route that has a parameter request and a parameter response. You're going to always pass those in. Because that's just what Express is that is what Express uses to work as an API server. So, yeah. that's all that's going on there. Don't be too worried about it too much. And then all that's going on here is that this is, another function that's going to be called once this query is executed. It'll call this function and supply parameters accordingly. If there's an error, it'll supply an error parameter. If there's no error, it will provide null, so it'll skip over that and then go to the else statement, at which point we send back to the client using the res parameter that was specified up here. We send back to the client some information, as you can see right there. So that's all that's happening there. Don't get too confused about it. I highly suggest that you take a look at callbacks if you haven't looked at them, as with course. Okay, so now the changes. So the changes occur in the .environment file. So this is creating a connection based on a bunch of variables that we set in our .environment file. So we're going to go ahead and take a look at that .environment file, and as you can see, we have some information in here, but some of it is empty, and that's because we need to still fill in these empty values with our own. So what we're going to go ahead and do is we're going to go back to Firefox, and we're going to take a look at our database. And our database has actually been created, so that's good news. And you can see it says available, and for whatever reason, Amazon is just being a little bit sluggish today, I guess, but it hasn't updated up here. Usually it'll say a green banner at the top saying that it has created. But we're going to go ahead and click on View Credential Details, and we're going to take this master username and master password, and we're going to add those to our environment file. So the first one we'll take is this master username, and we'll just go ahead and copy and paste that in, making sure there's no spaces before or after the value, because those will be included in the environment variable if they're there. And then we're going to copy our master password as well, and we're going to go ahead and paste that in so we can use that as well. Once we've pasted in the master password, we can close this, and then we can actually click on the sample docker-compose database, and you'll come up to a page that looks like this. And from here, we can actually take the endpoint that is specified right here under connectivity and security, and we're going to go ahead and take that, and we're going to paste it right in here where the host is, and we're going to save that file. So now we have all of the necessary connection information that we need in order to connect to our database using the API server. Now, the one thing that we need to do, though, is that when working on a team, you're going to have multiple IPs. And right now, the sample Docker Compose security group, we need to make sure that it actually has inbound access to everyone on the internet, because it might not. So to check that, we're going to go to this sample Docker Compose page that we see here. I'm going to close this because we don't need it anymore. We're going to go to this this connectivity and security tab on the actual database instance, and we're going to click under security. We're going to click on the sample Docker Compose VPC security group. So once we click on that security group, we're going to look down here, and we're going to make sure that our inbound rules are set correctly. So as you can see right here, it has MySQL Aurora TCP 3306, and the source is 0.0.0/0, which is CIDR notation for everything on the internet. And then we have the same for IPv6 connections as well. This is key. You have to have these two lines of inbound rules. If you don't have these two, then you're going to have to click on Edit Inbound Rules, and you're going to have to add a rule or alter one of the ones that you have, and you're basically going to choose the actually, I think we're not going to add a new rule. Because the way it'll work is because we specified it to create a security group when we set up the server or the database instance, sorry. It's going to go ahead and create some MySQL and Aurora inbound rules already defaulted. So the first thing that we're going to do is, if you don't see what you see right now on this page, you basically need to replicate this, and you can do that by simply changing this and clicking anywhere. I'm not going to change it because it's already set correctly, but if you just change that to anywhere, it'll add it. It might add like 2, right? So you'll see that it has 0, and then it has also has the IPv6, in which case you don't need this bottom one, but just make sure that you see at least this and this in one of the two of these. If you have it in both here, then you can get rid of this, but that is something that you definitely need You need to have access everywhere. Otherwise, you won't be able to connect to the database. All right. So we're going to go back and we're actually going to go ahead and make sure, yeah, so the outbound rules, we have it all open. That's good. And we also have those inbound rules set so we can access from anywhere. So that's really good. And I don't think we'll have any issues there. So now what we're going to do is we're going to take a look at DBeaver. So DBeaver, like I said before, is a connection client. What it does is it basically will help. It's a really nice interactive way for you to interact with your database. So I highly suggest that you use it. Another one that you could use is MySQL Workbench, although that has a lot of bugs right now. I would just, I mean, DBeaver is really good. It's free, it's open source, and it works well. So I just, I would just get this one if I were you. Or you could do it all using command line and doing, MySQL, just coding in the values using the CLI. I think that's kind of a waste of time if you're just doing database administration, like if you're just trying to set up initial values and stuff like that. But if you want to do it that way, by all means, you're more than welcome to. So what we're going to do is we're going to go ahead and open up DBeaver. And we're going to start up. You come to a window that looks like this. The first thing that we're going to do is we're going to create a new connection. So to do that, we're going to click this little top button up here in the left-hand corner that says New Database Connection. And we're going to go ahead and search for MySQL. We can see that MySQL is there. We're going to select it. We're going to click Next. And in the server host and username and password, we're going to go ahead and copy over the information that we saw here. So I'm going to go ahead and grab this URL, which is going to be my connection. 3306, because that's the port that we specified. Database, we haven't set up the database yet. We're actually about to go do that. And then we need our username and password. So our username is admin, and our password is that jumbled bunch of letters and numbers you see there. So I'm going to paste in that, and I'm going to change this to admin. And we're going to click the test connection button down below. And just as we expected, we get a successful connection. It shows us some information about the MySQL server and the driver, and we're going to click OK and just click Finish. That'll add the connection, the new connection, to our side panel here so that it saves it, so that in the future when we want to connect, all we have to do is double click this and it'll automatically connect to the database for us. Now that we've connected to the database, you can see we have some folders here. But what we're primarily interested in is the databases folder, because that's where our database will reside. So from the databases folder, what we're going to go ahead and do is we're going to go ahead and click on this button right up here that says SQL Editor. This will bring up a new SQL Editor window, of which we're going to insert some statements to set up some initial tables and also insert some values. So from here, what we're going to do is we're actually going to go back to our backend folder. And we're going to go to the MySQL setup.sql file that I have provided in the Git repo. You don't have to do this for your project, but I would do it, change these values as you need. But this is basically going to create a database and then create a table in that database that we're going to use in our project. So I'm going to copy that whole file, and I'm just going to paste it in here. And as you can see, it has some comments. So we're going to create the database, use it, create a table, and then insert a sample value into that table. So once we've done that, we can then click on this little run script button right here, which will execute the full script and all of the statements in it. So as you can see, I clicked that button. It ran through all 4 lines, all 4 statements, and it had 4 queries with 2 updated rows. So now that we've actually done that, we can actually click refresh on the bottom here. Oops. I think that might have been, I don't know what that was. Anyways, I thought that might work. I guess it did not. We'll go over here to the databases, and we're going to right click on the databases thing, and we're going to click refresh. And as you can see, our DB database that we just created was created. So we can go ahead and click on that, and we can click the little drop down, and we can click on tables, click the little drop down, and we see the test table that we just inserted is right there. So if we double click that test table, we'll see information about the columns. You can even add new columns here if you want. You can change values. You can set one to auto increment. You can do your primary keys, your secondary keys. You can do tons of editing here, and it'll just generate the SQL code for you and spit it right into the database, which makes this tool really useful. You don't have to like go and figure out what exact commands you need and parameters. This kind of just does it all for you. And then if you click on the data tab, you'll be able to see the data that's currently in that table. And as you can see in that table, we have our ID column and our value column that we created with our script right here. And we have that sample value that we inserted, right? So the ID is auto increment, so we didn't have to specify that, but we did insert into value a value called sample value. And you can see in value, we have that value called sample value, right? So now that all that is set up correctly, we're pretty much ready to go, and we're ready to start up the app. Before we do that though, one other cool thing about this is if you wanted to get like it provides ER diagrams. So if you wanted to get like an ER diagram of your entire database, you can click on your database and you can click on the ER diagram tab, and it'll create an ER diagram of all of your stuff and the related associations between all of them. So that's really useful for presentation purposes and stuff like that. If you want to get information, it's really good. So that's basically just a little mini intro to DBeaver. I would highly suggest that you guys get it, take a look at it, and you can always check documentation online for more advice and information on how to do that stuff. But now that we've kind of done DBeaver, we're actually going to go ahead and connect to the database and set up our project here. So everything has been set up accordingly. So we're going to go ahead and open a new tab there. And we're actually going to go and open a new terminal at the root of the project. So we're in the root of the project. If we type in ls, you can see we have our backend folder, our front end, and our docker-compose. And the first thing that we're going to want to do is make sure that we have our packages installed in our respective front end and back end folders. So if we go into the front end folder, we can see that we have the node modules file or folder and the yarn.lock file. If you don't have these two, you have to type in yarn or npm install to install them. And then we'll do the same in the backend folder. Just double checking. Yep, we have our node modules and we have our yarn.lock. So now that we know we have everything there and we know that it will be able to start, we're going to go ahead and do docker-compose up. And this will start up the docker-compose project like we've seen in the past, and it'll connect and work. So anyways, what happened here, right? So we started the backend API. It went ahead and started. It started using nodemon because that's what we just specified it to do so. And we have information here showing that it was able to connect to the DB and it was a successful connection. And then down here we see that our front end React app has actually also started. So we can actually go ahead and browse that now. So if we go back to our web browser and we type in localhost 3000, we can see that the page is working and we actually have that sample value that we stored in the database. So we can start, adding numbers here and seeing them be inserted. And if every number that we enter, so, we enter in 6, it'll insert 36, all that kind of stuff. If we go back to our DBeaver, we go to our test table, we click on data, and then we click on the refresh. I'm not really sure how that works. That doesn't seem to work very well. The way I usually do it is I just right click and do refresh. You can also hit F5 and it will refresh. And as you can see, we have the exact same values, right, that we were expecting to see that we entered. So we have sample 25, 1156, 36. Those values are exactly as we see them on the front end here. And if we click the reset DB, it'll delete that, empty out the table. If we go back to DBeaver, refresh this, we'll see that it's been emptied out. And then just to double check, we'll do one more insertion. Go ahead and check DBeaver, do a refresh, F5, and the value is inserted. So that's showing DBeaver's working, that's showing this is working, everything's connected, and everything is great. So from here, what I'm going to go ahead and do is I'm just going to go ahead and close out of this connection. So I'm going to click on the disconnect, which means that it's going to stop the connection. I don't want to save the changes to that script because I don't really care. So I'm just going to close that. That doesn't matter to me. And then the next time, I wanted to connect again, I can just click on connect and it will connect to the database for me. And I can go ahead and do the exact same thing I did. And you can see it's all right there. But I'm going to go ahead and disconnect because I don't need to be connected. And then we'll close out of DBeaver. And then from here, so we're that all worked. You can see all of the logging information that's gone on in here. But it's time to shut this down. So we're going to do Control-C, docker-compose down. And then that'll close out of the project, remove the containers, save off everything that we need. And just like that, we are done. And we're back to where we started, I guess, before we actually was working on the project. So in this video, basically what we just did is we set up a MySQL RDS database using AWS, and we also set up the connection for that in our sample Docker Compose project. We also altered the security groups to make sure that they were accessible from everywhere. And lastly, we used DBeaver to connect and manage our database and insert some sample values and initially set it up. So with all of that information, I really hope that it provides some insight on how to get started with this stuff. There is a lot of information out there on the internet, and sometimes a lot of it can be wrong, which is unfortunate. But I hope that this kind of helps. It should help kickstart your projects and get you in a place where you're feeling good about it. And again, if you guys have any questions at all, please don't hesitate to reach out to me or leave me a message or drop a comment. Yeah, that'll be it for this video. Thanks for listening, guys, and I'll see you next time.